It's on the south, passing to the right side. We'll come back to the sunspots momentarily, as the intensified solar wind stream has continued at a modest plateau, but the enduring above-average intensity is driving a bit of geomagnetic instability. It's the yellow bars at the bottom. Solar flaring is getting a little jittery in the wake of the appearance of the sunspot group. Its crackling morphed into proper umbral magnetic fields with small-scale interaction potential near the center. The sunspots were born almost exactly center disk and have been growing as they spread here. Taking a bit closer look at the sunspots reveals that they lack well-defined penumbra, but each has a light bridge severing the sunspot in half. The magnetism of the sunspots suggests strong interaction potential across them, with development and spreading having an excellent chance to continue the X-ray flare production at this sunspot group for the next 2 or 3 days. Eyes on it. We're going to the science news next, but we're not going far. A solar tidbit. Scientists are beginning to believe that the mystery of the super-high coronal electron temperature might be solved at the chromosphere, where those small-scale fields interact and indeed have their flares. The constant nano-flare energetic events pretty much wholly deposit their energy in the upper solar atmosphere. Well, folks, it's another week, another confirmation of electroquake science. Of all our pillars of coverage, this is probably the one furthest along in marrying the mainstream. There are textbooks, hundreds of studies, including those showing how the sun works these electromagnetic processes. And today, we see another in the low-frequency wave range. These electromagnetic emissions are often seen going anomalous in the days before larger seismic events, and that's exactly what we see here, about a week warning if we can pick out those subtle signals. Folks, the observational confirmation of the galactic sheet effects in our galaxy continues following the discovery of another in M51 earlier last week. Even in the messy version here, I believe you can see the wave on the left side, which helps you see it on the right. Cleaned up the double layer and crossover where the ripple overlap occurs is a bit to the point, isn't it? The best observation of the hydrogen traces nodes and filament concentrations along the wave, especially where it's interacting with the dense layer of the galactic disk. That's nova output enhanced return and field connectivity in the filaments. It's exactly what you would expect to see. This is from the Parker spiral, ionic wind, and magnetism of a sphere magnet rotating system in space. The disk that contains the moons, planets, or stars in the galaxy is a rippling current sheet, and the toroidally wrapped magnetic fields connect the peaks and troughs of that ripple back to the north and south poles of the central node, while the equatorial field runs through the wave. Now, at the sun's level, while we orbit in a year and cross the sun's equator twice in that time, its current sheet hits us every week to 10 days and can cause geomagnetic storms even without solar flares, coronal holes, or CMEs. At the galactic level, there are no CMEs or flares, but the rippling current sheet can produce the electric current induction and magnetic field coupling to the sun, just as we see on Earth, except this is the galactic magnetic reversal, and it happens much more often than we orbit or cross the equator. Yesterday I mentioned that the purpose of this channel, and our website, our books, our app, is to lay out and describe the ongoing processes and where they're all heading. Well, the crescendo is this: a long-period recurrent solar micronova. It explains the impactors, the magnetic event on Earth, the biosphere depletion, the Earth turning over as the crust is unlocked at the low-velocity zone, the nova-level isotope fission tracks in the bones of animals, and the rapid ice age as dust blocks out the sun.